All right. We are looking at naming of alkanes, cycloalkanes, like we mentioned in the previous lesson. So hope everyone is getting me, and we'll be able to name one or two alkanes, cycloalkanes, and many more. So these characters, CH260, ICH260. So that is the pure biology, pure chemistry, and also education chemistry, even the biology guys, the industrial guys, they are able to take this. So pay attention. These are just the same thing you find in an exam. So it's up to you. Everything is made easy for you. So for alkanes, once you are done with this, then you are done with alkanes. So long as you watch the video, then you are done with the alkanes. So everything is there if you want for private lessons. You're having challenge with biology, organic chemistry, you can inbox there. That is the line. Okay. So without wasting our time, we can start. So one thing that we need to know when naming alkanes is that first identify the longest chain, all right, in the carbon phase. So if you have like this, at least which one could be, you can count 1, 2, 3, 4, but the longest chain should at least contain a lot of carbon. So you can 1, 2, 3, 4, 5. So that this chain will be considered a longest chain. That's what I mean when I say a longest chain. All right. Okay. So then identify the branch if at all they are subsequent or groups. All right. Then the branches are called alkyls group, all right? For example, one carbon is called a methyl group, all right? If there are two carbon as a group like that, then that is other where it is attached. So we call that as ethyl. If there are three like this as a group, then there's other there that is propyl because we'll say 1, 2, 3 like that. Okay, so the names of alkyl groups are the same as those of, just that they will contain what? This alkyl group. So if it's a branch, we would have named it as what? Propane, but this will be propyl. You get me? So instead of propane as their actual name, then there will be propyl. All right. So we add this one to make propyl. All right. So, okay. Let me do this. All right. Okay, so that is it. So the following are the examples of most common. Let me just give you some examples. All right. What we need to know as we'll be studying these or naming these compounds, we'll meet some special groups. Okay. So these special groups, first of all, like I said, if we have a carbon, all right, just like that, this will be just there are two carbons there. Let me put other there, all right, where to be attached to the main chain. So we have 1, 2. So these are the, as a group it will be called, all right, there are two carbons to be called ethyl. All right, if it was just a normal alkyl, it would have been ethane, right? I mean, if it was just a normal alkane, it would have been ethane. So it's a ethyl as a group, like we said, we add YL. All right. So there are other groups such as when you see something like this, where it is attached there, where it is attached. So I'll say this group now is, this one is, don't consider this carbon, it's just an attachment. So there are how many carbons there? There are how many carbons? So number of carbons there, 1, 2, 3. That means that's a propyl, right? Okay, so that's it's a propane if it was just a normal alkane. So now as a group like that is making that V or Y, we call it iso, all right? So the moment it makes this Y like that, a V, it's called iso. So this is how many carbons? 1, 2, 3. So this is isopropyl. All right. If it has a lot of them like that, it has made a V. I've seen. Then again a V, it has a branch there. All right. Let's say the R is their way to be attached to the main chain. So it means we have 1, 2, 3, right? Then we have added another carbon there. So that means that will be isobutyl because there will be 1, 2, 3, 4 carbons. So this is iso. So the presence of that V tells you the iso naming. So it's isobutyls, isopropyl. So this is isobutyl. All right. So that is it. So again, if I have again more of these V, so I've put like this just to see. But each junction there's a carbon, like I've been saying. Okay. So we have 1, 2, 3. We have now included another carbon there. All right. So let's say the other group is there. So we have 1, 2, 3, 4, 5, right? So here we have iso pentyl from pent 5. So this is iso pentyl. All right. So that is it. That's how we'll be naming these guys. So the other thing that I need to tell you is the other groups again that I want you to be aware of. The Okay. So if you find something like this, all right, 1, 2, 3. Okay, there are 4 now. All right. So this is what a butyl, right? Because it's a butane with the 4 carbons. So but 1, 2, 3, 4. But it is a butane. As a group, it will be butyl. All right. So in this butyl, if I'm to attach a carbon there, all right, let me just show you something. If I'm to attach a carbon there, all right, I attach a carbon there, all right, then that is my other there. There are how many? 1, 2, 3, 4. So if there's a carbon there that I've blanched, this is making a circle like, right? So this is the iso. I mean, not iso. It's making a circle. So that will be sec butyl. All right. So that will be sec butyl. All right. So again, when it is making a V like this with something demarcating like a chicken leg, so this will be now, how many are there? 1, 2, 3, 4, right? There's an arrow where to be attached there. There are 4. So this is a tet. There are how many carbons? 30 butyl. Remember, we are from writing sec butyl. This is now tet butyl. All right. Pay attention to these, actually, these special groups. Isobutyl. We have talked about all these. So I want you to master especially this and the sec butyl and the tet butyl. I want you to know them. Okay. So that is it. And let us see some examples now. We have seen now how we can name these. All right. Let us see and work out a lot of things. All right. So we are asked to name the following. All right. So number 1. All right. So how do we name these compounds? So first of all, first consider the look at the longest chain. So for me, I can see 1, 2 there, 3, 4, 5, a pentane, like, right? But you need to look at first you number, so that the way you should number, try by all means to have the group to have a least number in your numbering of the main chain. So the way I would do this, all right, The outdoor, I can't start from there because it will get 4. If I start numbering from here, my branch will get what? We respect the branch other than respecting the what? The first priority should be given to a parent chain. You look at the longest chain. And the second, try to, at least in your numbering of your parent chain, give the subsuit or the group a list number. So if I'm to count from here, 1, 2, 3, 4, 5, my group will be what? Will receive carbon number 4. But if I'm to look at from the other angle, I start counting from 1, from this carbon of our right side, 2, 3, 4, 5. So here it's receiving what? Carbon number 2. So this is actually giving a total of, so which one is greater? Between 4 and 2. So we consider this way. So we'll name that way. So we'll say at carbon number 2, all right, we have what we call, what group is this? Is a methyl. So we'll say 2, all right, methyl. Okay, you give, whenever you write a number, separate with a dash with a letter. Okay, so methyl, all right. Methyl, then write the parent chain. The parent chain had how many carbons? It's a straight chain. So it's a what? Pentane. All right. Methyl pentane, like that. So that's how simple it can be. Then number 2. So we are also to name this. Again, this will matter. We can start numbering from here. First, we consider the longest chain. So I can say 1, 2, 3, 4, 5. No, I still have a lot here. So I'll go 1, 2, 3, 4, 5, 6, 7. I can go 8 or 8. That side, still the same. Let me say 80. All right. There's no harm. All right. So, all right. Then that is it. Then that is 6. That is 5. That is 4. That is 3. That is 2. That is 1. Okay. So that is it. Again, there are two ways here. Again, there's a group here. You have seen? So I can start numbering also from here again. All right. Okay. So I can say, all right, 1, 2, 3, 4, 5, 6, 7, 8. You have seen? So now I have two groups. So I'll total which one will be my, I have two roots, whether starting from right or left or right from left. Okay. So what I'm going to do is I'll get for the lead one. Lead one is giving me what? 4 plus 7, right? Then white, black one is giving me what? We have there 2, right? At carbon number 2, we have the group, and also at carbon number 5, we have a group. So which one will be the least? So here we're getting 7, here we're getting 11. So we'll go with the black one where we got less number. So that's, this please should be in your head. Always pay attention to the least number. Look at the two groups. Which one, which root is giving you the least number for the substituent or for the groups? So I'll consider this way of in a black number. So I'll say at carbon number 2, I have a methyl there, all right? Comma, all right? And again at carbon number 5, I have a methyl. So you separate numbers with comma, then you separate numbers with letters with a dash, like that. So how many are there? There are methyls. There are 2 methyl. I would have written just methyl, but they are not together. So I will write methyl, but how many are there? There are 2. So I'll say dimethyl, all right? Dimethyl, then you put the longest chain. So the longest chain, the parent chain is what? Octane. Okay, so that's how you can name this. Dimethyl 2,5 dimethyl octane. All right. So that's how you can name that one. Let's go to this one as well. So here again, this is a methyl. Whenever you just see a carbon or an arrow hanging like that, just know that there is also a methyl there. All right. That's the meaning. So we have 2 groups, 3 groups, all right? So again, the way we name these groups will matter. See, if we are to start numbering from here, I'll say 1, 2, 3, 4, 5, 6, 7. This is the longest chain I can see for myself. I can't go anywhere. These are just groups. The parent chain is an alkane with the 7 carbons. So again now, I can still number it again in a opposite way. So I can start numbering to say 1, 2, 3, 4, 5, 6, 7, right? Still giving 7. Okay, so from there, what are we going to do then? We do the same which we did, all right? We'll see which one is the best. Okay, so what I'm going to do is I'll say, first of all, if I'm to consider this, we have 3 groups, right? We need to try by all means to give these groups a list number. Where can we have a list number? So what I'll do is I'll add these 2 plus in lead. I'll say 2 plus, all right? At 3 also there's a group, plus at 6 there's a what? A group, all right? Then I have also at 6 in bracket, at 6, okay, plus again at 5, okay, plus again at what? 2. All right, so this plus this, that is 11. This plus this, that is what we have. 5 plus that, that is 11, 13. Okay, so this means that we go with the lead one. Okay, so please master this trick. So we'll go with the lead one, all right, where we get the list in the way we actually prioritize these numbers. So the other way is, what we need to know is that there is the bromine, which comes first in the alphabet code, and then chlorine follows, then M follows, right? So we'll be naming them following the alphabet code, apart from just knowing the names, all right? So I mean numbers. So we go like that. So we start numbering now. We start with this guy, which is what? At carbon number 6, there's a bromo, all right? As a group, it's called a bromo. We did this in the introduction to nomenclature. So 6 bromo, all right? 6 bromo, all right? You separate again. There's at carbon what? At carbon number 2, there's also a chloro, because bromine comes first as B in the alphabet code, and then chloro comes second in alphabetical order, all right? Then again we separate. There's another group which is what? A methyl at carbon number 3. So say 3, again we separate with a letter like that. Then we write the same methyl we have, all right? After writing methyl, now we write the parent chain. The parent chain at 7, so that is hept, and it's there's no double bond, so that would be heptane. Okay, so that is it. That's the only way we can name this. That's the correct. So that's how you name this. Okay, we do more now. All right, so looking at this now, again we can start. These ones I've already counted them. I've already demonstrated the way to go, because if I'm to start numbering from 1, 2, 3, 4, our branch will receive 4 than using this way where it will receive 3. So we'll go with the way it will receive 3. So how do we name this now? So we'll say, okay, so at carbon number 3 now, say 3, all right? There's what? Is it a methyl, propyl, what? This is just an ethyl, right? So I'll say 3 ethyl, all right? 3 ethyl, all right? Then hexane, because they are what? They are 6 hex, all right? So hexane is an alkane. So also here, come and look at this. So I hope everyone is getting me in this meeting. I can start counting from here. I can say 1, 2, 3, 4, 5. You've seen 6, 7, 8. Our group will receive 5. So I'll go with where the group will receive 4. The numbering of starting from right. So this now, if would have considered, if it was going to give us the longest chain using it, would have used it and destroyed this special group. But one, you have remembered this special group. I know I've talked about this special group, so we'll see how we can name that special group. All right, so we can now go with this way. At carbon number 4, we'll have a group. So say 4, all right, let me say this is 5, all right. At carbon number 4, all right, so say 4, okay. What is this special group that you can see? 1, 2, 3. It is an iso, like I explained to say when you see something like this, that is an iso. So that is an iso, all right, iso group. So say, all right, yeah. So 4, at carbon number 4, there is an iso. You separate always with a dash. So you say iso, all right, iso, isopropyl. It's a propyl. The virtue of having this V is iso. Then how many are there in that V? There are 3 carbons. 1, 2, 3. So that is isopropyl. All right, as a group. Then what is the parent? It has 8. So that is octane. All right. Then what of the second one? I mean number 6. So number 6 we have again we have a special group there. You have seen this is nice, and it's just similar. I'm sure you can try. You can pause the video and try to attempt to this. So also at this point now, number 6, what we are trying to say now is, first of all, I want to consider this group. First, let me check the way I'll have the longest chain. All right. So if I'm to count from here, 1, 2, 3, 4, 5, I'm getting 5. But if I'm to use the where there is lead also branched, I'll say 1, 2, 3, 4, 5, 6. You have seen I'll receive at least a 6. So I'll get either this one, I can write 6, or here, still the same at this point. So 5 there, then 4 there, then 3 there, okay, then 2 there, then 1 there. All right. So that's how I'll name. So I'll have the longest chain with the 6, not 5. So I'll destroy the special group that you wanted to use. All right, so that means we are going to name it in that way. All right, so we have how many branches now? At carbon number 5 we have a methyl there, and also at carbon number 4 we have a methyl there. So there are 2 methyls that we have, right? So this is how we name it. At carbon number 5 we have a methyl there, and also at carbon number what? At carbon number 2. So I've counted to say 1, 2, 3, 4, 5, 6, right? I've destroyed that methyl group. Why? It's because that's the longest chain I can see. All right. So that means we'll use that one as the longest chain. So we'll have 1, 2, 3, 4, 5, 6. We have 6. Let's start see now the groups. All right. So I've just counted from this, starting from this. Again, I'll use another way of numbering because I can see a lot of groups and I need to see the way I'll start numbering. Starting, and let me start also from here to say 1, all right, 2, all right, 3, 4, 5, 6. Okay, so again I'll do the same. Lead or brew, which one will give me the least number in the way we have considered the longest chain and the way we can actually number it? Is it starting from right or starting from left? Now starting from right, we're getting at carbon number 2 there's a group. All right, at carbon number 3 also there's a group. At carbon number what? Just these 2. Then also now considering this one this way as well, at carbon, using this one, at carbon number 4 there's a group, and also at carbon number 5, definitely the one which will give us 5 wins, then this one is giving us 9. So we'll go with what? The lead one. All right, so that's how we'll do this. Okay, so that is it. Then from there, what we are going to do is now we'll use this numbering to say at carbon number 2 and carbon number 3 we have groups. So at carbon number 2 we'll say 2. Okay, same with a methyl, guys. So I'll say 2 comma 3. All right, then we separate a number with that. There's a di, all right, there are 2 methyl, so say dimethyl. If there were 3, we would have said trimethyl. All right. So dimethyl. All right. The parent chain was what? 6. So that is hex. As alkane, that is hexane. Okay, so that's how you can name this structure. So coming to also this one, number 7. Okay, so the way we name this one, we say we can also start numbering from here. 1, 2, 3, 4, 5, right? Or again, I can start to say 1, 2, 3, 4, 5. Okay, so which one? I think this is giving equal stuff. Which one will have the list as well for the group? So at this one is getting what? 2 plus 2 for the second naming is giving me 8. And also this 2 plus, not 8, 6. Why am I in hurry? Okay, at carbon number, this is giving equal. When you add 4 and 4, it's giving 8, 6. And also this and 2 is giving still 6. So this doesn't matter. So the way I'll do this, you choose, you prioritize, like you choose any naming. So I know it's 2 and 4 which will appear in our first naming. So we'll say we have 2, comma, 4, all right. Then there are all methyls there. So we'll say di, all right, methyl. Oh, you can start with the capital letters for this. So say dimethyl. All right. So it's a dimethyl. Then what is the parent chain? The parent chain has 5, so that would be a pentane. All right. So that's a pentane. Now we can now do number 8. Okay. So again, if you are able to see now, we have a lot of methyls groups, okay? So again, numbering here, I can choose, my go first is to look at the longest chain, all right? So the longest chain now will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I would start numbering from left. So this will be our carbon number 3, this is our carbon number 4, this is our carbon number 5, this is our carbon number 6, 7, 8, 9. All right. So having that prefix, it will be on a non, just non. Okay. Then as an alkane, it will be a nonane. That will be the parent. So now what we are going to do is we'll say, we'll again do the opposite in the way we'll number. So I'll start numbering the opposite way. So I'll start numbering from here to say 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let us do the magic again. We add these and we'll see which one we use. For black, starting from right, naming, going this side. So say at carbon number 4, we have a methyl. At carbon number 5, we have also a methyl. At carbon number 8, we have also a methyl, right? So we'll total that. Again, starting from left, at carbon number 2, we have a methyl. At carbon number 5, we have a methyl. At carbon number what? Number 6, we have also a methyl like that. So, okay, so carbon number 5, 5, 5 does, given the same. Then carbon number, so when you add this and this is what? This is 9, 9 plus 8, that is 17. All right, that is 7, 7 plus that, that is 13. So this means that we'll go with the least one. So hence the one with lead, it will give us the collector. So we'll go with the lead numbering. Okay, so that's how we'll name this one. Okay, so that is it. That's how simple it can be if you use this trick. So we go now. Okay, so we start now with this one. So say at carbon number 2. So start numbering from this, all right? At carbon number 2, all right? Again, at carbon number 5, Again, at carbon number 6, all right, we have what? You separate always numbers with the dash. Okay. How many methyls do we have there? There are 3. So say try, all right, trimethyl, like that. Okay. Trimethyl. Then how many carbons in the parent chain? There are 9. So that is known as an alkane. It will be nonane, all right. Nonane, like that. Okay, so that's how you can, that's how simple it can be. So we go to number 10, I mean 9, 10, like that. Okay, number 9. Also here, what you are going to do is we'll look at the parent chain. So I can start numbering. So let me follow the black route. I see 1, 2, 3, 4, 5, 6. Okay, so that means I have hexane, right? Also, let me try another way. 1, 2, 3, 4, 5, 6. Still the same. Again, let me try this. 1, 2, 3, 4, 5. So I'll just use the black one. All right, I'll use the black way. So this means that we have 1, 2, 3, 4, 5, 6, right? So we have a parent chain as hexane, of course. So let us see now these groups. Okay. So numbering again matters. So say I can start numbering to say 2, 3, 4, 5, 6. Okay. Again, I can also start numbering from the other way around. I can say 1, 2, 3, 4, 5. Okay, so these are not the same groups, okay, but we'll see. Let me start now getting the statistics. So we have 5 there. For red we have 5 and 3, that is giving 8. For black we have 2 and 4, that is giving 6. So we use for black way. So numbering we use black one now. Okay, so now the name will be, okay, so how do we name this now? So our name now will be, okay, so we have, now we can start at carbon number 4. All right, we have ethyl, not methyl, but ethyl with 2 carbons, like that. So that will say carbon number 4. At carbon number 4, all right, we have, you separate always like that. So we have an ethyl there, all right, ethyl. Then we separate also with a dash like that. Another group now comes at carbon number 2, okay. Then we separate again, it's a methyl, so you say methyl as a group. It's a methane, but as a group it's a methyl. Then the parent chain is hexane, right? So it will be, the name would be 4-ethyl 2-methyl hexane. All right. So that would be the name of this structure. So again here, I can identify a certain special substitute or a group, which is an isopropyl. So you remember this. I've been talking about this. So to name this now, what you are going to say is, again, we'll start numbering again, but this is giving equal if I'm to start. But if I start 1, 2, 3, 4, 5, 6, 7, that is the heptane, all right? So if again I'm to start numbering the way round in the opposite way, so I'll start numbering from 1, 2, 3, 4, 5, 6, 7, all right? So this and 2, and let me get for black one, we have 2 plus 3 plus 6. Then for red we have 6 plus 5 plus 2. Okay, so this is giving me what? 13. This is giving me what? 11. All right, so we'll go with the what? The first one, this one. All right, where we get also for methyl the list number. I mean for ethyl as also a list number. So we'll go that way. All right. So what we are going to do is we'll say, we'll start numbering now. So we'll say at carbon number 3, first of all, this is an iso, right? This is a meth, right? This is a meth again. So which one comes first in the alphabetical order between between I and M? Of course, it's I. So we'll go with first the group where the iso is. Iso what? Propyl. So I'll say it's at carbon number what? Carbon number 3. So I'll say 3, all right? Isopropyl, all right? Isopropyl. Then we have 2 comma for these two guys. We have at 2 and also at 6. Okay, so again we attach. Now what are these? They are methyls, so it will be a dimethyl, right? So you say dimethyl. So dimethyl. Then what to be, how many carbons are there? They are 7, right? So that is a heptane. That is a heptane. So the name of this structure, it will be 3-isopropyl 2,6 dimethylheptane. So that will be the name of this structure. So remember these special groups like I've been telling you. Please master the iso, the tet butyl, stuff like that. So that is it. Now coming to the last one, question 11. So also the way we name this one, we say, how are we going to start numbering? First, we'll look at the parent chain. Do we have the parent chain? Yes, we have. We'll say 1, 2, 3, 4, 6, 7, 8, 9. So this will be actually my parent chain with 9 carbons. All right. Let me look at the groups now. I have a methyl there. All right. I have also a methyl there. Then there are how many carbons which are there? They are what? 1, 2, 3. That's a propyl as a group. All right. So that's a propyl as a group. So what I'm going to do is, um, I'll name it to say, let me start with which ones comes first in the alphabetical between P, this of propyl, and also M of methyl. Of course, it's M that comes first in the alphabetical order. So the way I'll name it, I'll say, I'll have at carbon number 2. So I'll start numbering from here because I want to get the list. All right, 3, 4, 5, 6, like that. So I'll say this is 7, this is 8, this is 9. So I'll say at carbon number 2, I have a methyl there, right? So I'll say 2 comma. At carbon number 6 also I have a methyl there, 2 comma 6. All right. Then you separate a number with a dash like that. How many methyls of them? There are 2. So we put di because there are 2. So it will be dimethyl. All right. Then coming to propyl. Now propyl, it is at carbon number what? Carbon number 4, right? So say 4. All right. Again, we say propyl. So what is the parent chain? The parent had 9, so that is known, right? So as an alkane, it will be nonane, right? So the name will be 2,6 dimethyl 4-propyl nonane. That will be the name of this structure. So that is it. That's how simple they can be if you actually master it in that way. So let us also look at the naming of cycloalkanes. So cycloalkanes, same as just these aliphatic alkanes, but these are the rules that will be followed. First, determine the parent chain 1, then number of the what? The number of substituent or groups in the chain should give you also the list like you have been doing it. Okay, name the substituents and place them in alphabetical order, just like we have been doing. Let us see what we are trying to say here. Okay, so first group we have is now this one. I've demonstrated how we can number it. So I've put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember, the goal is to at least this group, a main group, to receive a list number. Okay, when naming the parent chain. So what I'm going to do is I'll say, okay, This is my group that I have as what? A cyclo group, which is how many carbons are there? It's a triangle, stuff like that. So that is what? Cyclopentane, because they are what? I mean propane, because there are 3 carbons there. So that's a cyclopropane. Okay. So I'll just respect the group because the rest are not that important. Like this one, we respect the group first. The major group should receive a list number. So I'll go with this naming than me starting like that. Okay. So that means I'll name it to say at carbon number 3, okay? At carbon number 3, all right? At carbon number 3, I have a cyclopropene, so I'll say 3, all right, dash, you separate always, then you put your, this is a cyclo, all right, cyclo what? Propane, all right. So as a group now, it won't be propane, it will be propyl instead. Then is there other groups that we have? Yes, at carbon number 6, we have what? A methyl, so that will be 6, okay, you separate always the dash and the number, so you say 6, we have a methyl there, all right. Then what will be the parent chain? All right. The parent chain we determine to say it's a 10 carbon chain. So that is what? A decane. So it will be a decane like that. So the name of this compound, it will be 3-cyclopropyl 6-methyl decane. So that will be the name of this structure. So we'll go to number 2. So for this one, we have 2 cycloalkanes. But you look at which one is the biggest with a lot of carbons. So that will be our parent chain. So we have this one, 1, 2, 3, 4, 5. So that is what? A propane or just 5 carbons chain. This one is having 4. Of course, this will be now our group because it's receiving a least number of what? Carbon. So what I'm going to do is now say, as a group, I would have named to say number 1, number 2, number 3, number 4, number 5, like that. But doesn't make sense. Instead, what I'm going to do is I'll just say it's at number what? Number 1. We can't say 1 because the direction is already known. So what I'm going to do is, as a group, this is what? It's having 4. So that is what? Cyclobutyl as a group. So I'll say cyclobutyl, then as a parent now, I would have said 1 cyclobutyl, but I'll just say cyclobutyl. Then the parent chain is now is having what? 5. So it's a cyclopentane. So I'll say cyclobutyl cyclo what? Cyclopentane. Okay, that's how we'll name this one. Then coming to number 3. Okay, so this is also again a 6 carbon link. So that is a hexane, of course, cyclohexane, that will be the parent chain. But you look at the groups again. So use that trick for actually determining which one is receiving, which way is receiving the least number of carbon. So the way I've numbered for me is still the best. So you can do the opposite to give you a big number. So like this, you get it to say 1 and 3, they are giving you 4. But if I started numbering from here, 1, 2, 3, still giving you the same. So there's no change at this point. So better you choose the other way, the same way I've actually done it. So we'll say at carbon number 1 and number 3. So we have something at carbon number 3. So at carbon number 1, we respect the group. Okay, it's an ethyl. Which one comes first in the alphabetical order? Between E in methyl or M from methyl. So we'll go with what? The E in what? In ethyl. So the way I'll name it to say at carbon number 1, we have an ethyl there. So I'll say 1, all right. Okay. So I'll name it to say at carbon number 1. So at carbon number 1, we have an ethyl there, all right. We have an ethyl there. Then at carbon number 3, we have also a methyl, all right. Separate always a number with a dash when connecting with the letter. So a methyl is there, all right, at carbon number 3. Then the whole group is having what? It is an hexane. So it's a cyclohexane. So say cyclohexane. All right, so that is it. Then coming to the fourth one, we are saying now, um, also do the same. If these are just special groups, here we have methane of M. This is bromo. This is chloro. So we'll see now the way they appear in the alphabetical orders, in their using their first letters. So for this one, we have M, B, and C. So you can see that B comes first, then C, then M. So the way we name it to say, we name it as, all right, we name it as, at carbon number 2 now, they have just started it. At carbon number 2, all right, at carbon number 2, we have a bromo, all right. Then at carbon number 1, we have a chloro, all right. So I'll say 1 chloro, right? You indicate where you have found that chloro of yours, a chlorine group. So you say 1, all right, chloro, all right. Then again at carbon number what? Let me just connect that the way it continues like that. Then I'll put a dash again because I have another group which is the methyl. So from here I'll say 3, all right. Again I connect a methyl there. All right. So again I'll connect like that. But now I'm attaching the parent chain. I'm just showing you that I'll connect because I don't have a space. I'm not writing in dash, but I'm writing a parent chain there. So that means what will be my parent chain is having what? 4 of them. I mean 1, 2, 3, 4, 5. There are 5 carbons. So I'll say this is a what? Cyclopentane. So where there's methyl there, I'll write cyclopentane there. So say cyclopentane. All right, so that would be, so the name would be 2 bromo 1 chloro 3 methyl cyclopentane. That would be the name of this structure. So coming to the last one now, we have again at carbon number 1, the way I've just numbered it's still the best. You can also try the other way around. It will give you the highest number once you total those groups. So the best is the same we have started it. You respect where it is more actually heavier, where it is heavier or having more, I mean, a large molecular mass. So you consider that and start numbering from there. So I've started from here, okay? So at carbon number 1, they have 2 methyls, right? So I'll say this will be what? First of all, which one comes in the alphabetical order? There's a methyl there, right? And also a fluorine. So F comes first. So I'll say at carbon number 2, all right, we have what we call a fluoro, all right? Fluoro, all right. Then dash again at carbon number 1, again you separate with a comma. Again carbon number 1, we have what? 2 methyls, so that will be just a di. So don't consider this di as one of like characteristics when determining in the alphabetical order manner. No, this di is just trying to show you these two. Otherwise the main group is what? Methyls. So master the trick. So we have now, it's a cyclohexane. Okay, it's a cyclohexane. Actually, I haven't written it properly, but you can write it properly. It's a cyclohexane. So the name is 2-fluoro 1,2, I mean 1,1 dimethyl cyclohexane. All right. So these, you can try these. We have 10 marks there. So I'll demonstrate for you this one, then you do the rest. Okay. So what we're going to do is, it's a cyclohexane. So you start number and say, okay, it's a cyclohexane. All right. Okay, just like that. And anyway, I haven't written properly. Let me write it nicely. Okay. Like that, okay? This is 1, 2, 3, 4, 5, 6. There are 6, so it's a hexane, all right? So what I'm going to do is, you see, there are 2 methyls, all right? There are 2 methyls, dimethyls. So at carbon number 1, I can say at this one, that will be my carbon number 1. And also at carbon number 2, that will be. So I'm done with the first one. That's how simple it can be. Then coming to B, B, also it's a cyclopropyl as a group, then there's a butane there. Butane just as a straight chain. So say 1, 2, 3. Okay, 1, 2, 3, 4. This is a butane, right? So now at carbon number 2, there is a branch of cyclopropyl. So it's a cyclopentane, but it's now a group like that. So that would be the name, that would be the structure. All right. Then that is for this one. At carbon number 2, there is the cyclopropyl. Okay. Then this one, coming to this one, we have a pentane there, right? A pentane. So I'll say it's a cyclopentane. So I'll say 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. So in now we can start. I can choose a numbering to say this is at carbon number 1, where I will find a methyl, and also at carbon number 2 I'll find a methyl, and also at carbon number 3 I'll find a methyl, right? Then it's a cyclopentane. I've already done that. So that's how you can actually hammer this. Then also coming to D, we have also again D. So this is A, B, C. All right. Then D. D now again we go cyclopropane, so it's 1, 2. All right. Propane. So it's a 3 carbon. Okay. A propane is a 3 carbon cyclopropane. Then the group is what? Cyclopropyl. Again, there's another group which is cyclopropyl, right? Because we are saying cyclopropyl as a group. This is cyclopropane as the chain. So I'll just do this one. Still the same. It's like this. So this will be our parent. This is will be our group. Cyclopropyl at carbon number 1. There's no need, in fact, of writing number 1 there. Okay, just like I did for the other example for cyclobutyl cyclopentane, if you remember. Then coming to E now, we have isopropyl cyclohexane. So you start with this one, cyclohexane. So say 1, 2. All right. So there are 6 carbons there, right? So there's at carbon number 1, there's an isopropyl. So isopropyl N, you can branch at N. So isopropyl looks like this. You remember? So that would be the name, the structure. That is it. We are done. So that is for cycle. So keep practicing, keep watching the video. These are the things you find in an exam, I promise you. For your test 1. Okay. So thank you very much. Keep lighting, get your paper, and that means you have summarized alkanes, naming of alkanes. So your lecturers likes getting just these things from this. So from the video, you see things appearing there, the things that I was preaching each and every day. So pay attention, and you see positive results. All right, so that is it. This marks the end of alkanes naming. So watch out for alkanes.